In this video, I am discuss about the titrimetric analysis. What is the meaning of the titer? Titer means the solution concentration. Yes, when the solute is added into the solvent, then become the solution. As much as solute is added into the solvent, then the solution become more concentrated. So called as solution concentrated. Yes, so in the 1 ml of the solution, how much amount of solute is present we determine. In the 1 ml of the solution, what is the weight of the solute in the solutions we determine. Yes, so suppose you have the one solution whose concentration is not known, we have an unknown concentration solution. Yes, so in the 1 ml of the solution, how much amount of solute is present we determine, so called as these unknown substances. Yes, and these unknown substances determine with the help of this known concentration, whose concentrations we already know. So these known concentrations called as standard solutions, and in titrimetric analysis language called as titrant, which is filled in the burette. Yes, and we determine these unknown substances called as analyte, which are filled in the conical flask. When the titrant is react with the analyte called as the titration process. Yes, so in the solutions, what we determine, actually we determine the amount of the solute. We determine the amount of the solute, so actually we determine quantity. So that's why this is called as quantitative analysis, formerly called as the volumetric analysis. Why? Because we are talk about the volume of the solution. Yes, but nowadays we are called as titrimetric analysis. Why we remove the volumetric analysis? We remove the volumetric analysis because in the volume the gaseous substances are also involved, gaseous substances also involved, but we are not talk about the gaseous substances, we are not determine gaseous substances. So that's why we remove the volumetric analysis and nowadays called as the titrimetric analysis in place of volumetric analysis. So when the titrant is react with the analyte called as the titration process. Yes, so this is about the titrimetric analysis. Okay, so next we move toward the diagrammatic representations of the titrimetric analysis. Yes, so what is the diagrammatic representations of this titrimetric analysis is, so this is the burette, and in this burette titrant is filled called as the known concentration standard solution. Yes, and in the conical flask analyte is present, we determine the unknown substances. Yes, when the titrant is react with the analyte called as the titration process. Okay, so how to determine and how to know titration process is complete, titrant is completely react with the analyte, how to determine? Okay, how to confirm the reaction is complete? So we confirm with the help of this indicator. So this indicator is an auxiliary substances which show the clear visual change after the reactions between the titrant and analyte. Titrant and analyte is practically completed. Okay, so we show the faint pink color or turbidity or any other change, we know the titration process is the complete. So this is about the titration. Yes, and the point at which the reaction between titrant and analyte is just complete called as equivalence point or theoretical point or stoichiometric endpoint. So we have already a theoretical endpoint, and in this theoretical endpoint, so we done a practical, so we have some visible endpoint. So in theoretical endpoint and visible endpoint both have very approximate toward that, the value both have approximate toward that, means that the small difference between the theoretical endpoint and visible endpoint called as the titration error. Okay, so this is about the titrimetric analysis.